Hello friends, myself Rohit Solanki and today I am going to talk about hybrid spam filter which is based on the name-based classifier. As we know that spam is an email which is usually sent in bulk by the sender. But unlike legitimate mails, there is no agreement between sender and receiver. That's why they are also termed as unsolicited bulk emails or unsolicited commercial emails. To prevent the delivery of this so-called spam messages, an automated tool called spam filter is used. As there is no single definition of spam, it is difficult to formulate rules to block such unwanted messages. There are several techniques used to stop these messages, but even with the introduction of new state-of-the-art techniques, it is difficult to contain spam. Some of the techniques are based on manually configured rules, others rely on statistical calculation for adapting themselves to current situation. Also, there are some techniques such as collaborative filtering which requires feedback from the users. Earlier, most of the spam filter models were based on single classifiers such as KNN, AdaBoost, Naviebase, SVM, etc. But in recent times, combination of these different techniques have been proposed. This combination can be in parallel to increase the accuracy of the model or sequential to increase the acceleration rate. In this project, we have improved the Bayesian classifier. Bayesian filter works on the principle of calculating the posterior probability of message in terms of prior probabilities of class and features. Basically, this filter maximizes the likelihood function rather than focusing on the accuracy. But in this project, we have improved the accuracy of the filter. This diagram depicts the steps involved in the Bayesian model. Pre-processing step is the first step in this model. High percentage of the stop words are present in the emails. Inclusion of these words decreases the overall performance of the spam filter, as they are generally part of both types of mails. In pre-processing step, stop words such as an, a, etc. are removed. Another step involved in this is the stemming of words to its root form. For example, teacher, teaches, teaching, etc. all can be stemmed to the word teach. In the next step, tokenization is done. Tokenization is the process of dividing message in the form of tokens and assigning attributes to each token. In the learning step, conditional probability is calculated for all the tokens. As you can see, SW represents the probability of a token or a word W to be spam, whereas HW represents the probability to be ham. The final probability is calculated by a given formula. All of the 5 parameters are calculated in this process and spamity of each token is derived. In this project, instead of using a single classifier for all the users, multiple local classifiers and one global classifier is used. While training local classifiers, frequency count for the token is incremented through the posterior probability calculation across all the users. That is, in the original model, increment in the frequency table was constant. But in our project, we make use of the current knowledge of the classifier for further training. This is a general diagram of this project. As you can see, for user I, increment is calculated using global classifier, which is in turn trained through all the local classifiers. As we can see in the result, there is a significant improvement in the error rate and maturity of filter is achieved at an early percentage of training data. So in the end, following objectives are achieved in this project: improved classification accuracy, sharing of knowledge among users, and use of current classifier knowledge for further improvement. Thank you for watching.